All about arrays in less than 30 minutes, I promise. Let's begin with what an array is. To understand an array, we need to understand what a variable is. So if I go int ball1 is equal to 11, that's the position for ball, and I can go print line ball1, and if I run it, you can see it comes out with 11. I can treat the ball1 just like it is a variable, so I can put 99 into it. I can do that, and I can get the number out of it. So I can say int other equals ball1 times 89, and that will compute that number. And if the important point is, if I now go ball1 equals 2, what's other going to contain? So other. Let's just run that. Just to be clear, we understand what a variable does. So we start off with 11. We set it to 99. We then do ball1 times 89. Now it's going to fetch the value out of there, which is 99, and do 89 times 99, which is 811. But then if we set it to any other number, like 3, that won't change the value out of other. And let me just do it simply. I'll do 10. I'll do 20 here. And if we press run now, so even though ball contains 3, other contains the value that's been taken out of ball1. It's been multiplied by 20 and stuffed into other. And even if I change ball1, I don't change, the value of other doesn't change, because in Java and most programming languages, these aren't live formulas as you might be used to in a spreadsheet. Okay, now we've got the concept of order out of the way, and we understand what a variable does, which is just a container for a number. We can move on to what happens next. Let's do this. So we have a code that bounces a ball left and right, let's say, and it's working. So I want to have a second ball, and I'm going to start that one at 22, and I want to start that one at 33, 66, and so on, int ball 7, 60, 77. And of course, if I wanted lots of balls, I might take this code and go, oh, I just cut and paste it, don't I? So that's going to be ball 8, ball 9, ball 10, ball 11, 12, 14, 15. Okay, and you're thinking, okay, and I can just treat all these variables just like I did before. So I've got print ball1, print ball 2, ball 3. There we go. And if we run it, oh, that's ball 12, ball 14, ball 15. Let's run it. And obviously, if I assign to ball 11 ball 1 is equal to 8,000, we'll see it updates that value. There we go. It's very common to see this in code, but you end up with one big problem, and you've probably spotted it already. No ball 13. Okay, that could be problematic. The other problem comes to if I want to do something with them. I'm having to write this code. So supposing I want to print all the values out. So I want to print the value of ball 1, 2, 3, 4, 5, and so on, all out. 2, 3, 4, 5, 6, and you can fill in the rest with your imagination. If I press that, I got all the numbers coming out. But again, it's a lot of time consuming work, and if I'm cutting and pasting, I'm going to make this ball 13 error, and it will take me a long time to find that error, typically, because when you've got up to, say, int ball 2000, and if you're writing a game, it's not unknown to have 2000 bad guys in the game, or whatever, 2000, you're going to make a lot of mistake, and you're going to be typing a lot of code. So you might be asking, is there an easier way? Well, it turns out in Java there is. What we can do is we can say int ball, and then we use the square bracket syntax. So this is the key that's below the squiggly bracket you're probably more familiar with. So we can create an what's known as an array, and we say equals new int, and how big do we want this array? Let's make it 2000. Imagine how hard it would be to cut and paste all that stuff accurately 2000 times. And this has created ball. Now what's interesting about ball is just as we have ball1 here, we can say ball, once we've created it, we can say ball1 equals 11. Ball2 equals 22. Ball3 equals 33. So we can reproduce everything we've got here quite easily. But there's one extra trick. This is how you might allocate an arbitrary sized array. If we actually know what the values are in advance, we can go int ball, let's say people, let's just say numbers, I'm just making this up as I go along, equals 11, 12, sorry, it's 22, isn't it? 22, 33, 44, 55. So this is just, this syntax here is just a shorthand way of doing that with 1, 2, 3, 4, 5, 6 elements, and then initializing it. Ball 455. So this is a shorthand for this, and remember all of this does is a shorthand for that. So where before you might have ball 1, ball 2, here instead of having just the name of a variable, you've got this angle bracket syntax, square brackets around that number. So that shouldn't be a big leap for you, but it's actually a tremendous leap forward, because let's go to a simple problem like printing all these balls out. So let's get rid of all this old code, and we've got rid of ball. So here we want ball 1, ball 2, ball 3, ball 4, ball 5, ball 6. So far, so good. But what have we really achieved here? You might be sitting there going, well, it's no different from the earlier code with ball 1, ball 2, ball 3. But look what we can actually do. I can create a variable. What should we call it? Let's call it position. Int pos equals 1. And of course, I can go ball 1 is equal to 88. Yep. If I print ball 1 now, we should get 88 at the top. Let's do that. 1. And we get 88. So ball started off with 11. I've put 88 into it, and now I get the value out of it, and we can then access it, and it becomes 88. And remember, we can do with this with everything. So I can say ball 2 is equal to ball 1 plus ball 3. I can have any expression that requires me to get a value out of a ball, and it will work. Okay, and I should print that one out just to prove it. Print line ball 2. There we go. Let's forget all this because we're about to go one step further. So the number pos, the variable pos, contains 1. If I put pos in here, it looks in that value, which is 1, and gets ball number 1. Okay, so pos. So this is no different from the ball I had before. So pos is no different from 1. But let's just do this one. Let's do ball. Let's do this one. Let's go print line pos. Let's just prove that. So you have 88 in that one and pos in that one. Let's do this time. So let's do ball and pos. Again, I'm trying to do very small, simple steps so you're not confused. So this is the value 1, and this gets ball 1. Okay, we can do this twice now. And if we run it this time, it's going to say get the pos contains 1, and we're getting the value 1 out of it. And this says pos contains 1, we get the value 1 out of it. But now let's do this. Pos plus plus. That adds 1 to the value of pos. If we run pos now, it starts off getting the value of ball 1, then we add 1 to it. Pos contains 2, you can see the 2 there, so that we get ball 2, which is 22, which is that one. This is interesting. Let's just cut and paste that code again. And again. So what's going to happen this time, do you think? Let's have a look. So ball contains 1 here. You can see 1 there. It gets the value of ball 1, which is 88. Then ball 2 is 22. Ball 3 is 33. And ball 4 is 44. All these values we set up here. But look at this code. It's the same code over and over again. So yes, we could sit there and we could theoretically cut and paste that many, many times. But let's be a bit smarter. Let's do this. Let's go while pos is less than 6. So what this code is going to do is it's going to keep calling this routine, this block here, 6 times, because pos is going to be incremented. So let's do that. Oh look, so it's printed out ball 1, ball 2, ball 3, ball 4, ball 5. Now in fact, if we have 6,000 balls, and we use the, if we have 6,000 balls and we make it less than 6,000, we can print all those balls. There we go, all the way up to 6,000, because obviously we're less than 6,000. So what have we done here? Instead of cutting and pasting this routine 6,000 times, we can compress all of that into this easy 4 lines of code. And that is the big value of an array. If you can figure out how to do something with one item in an array, you can figure it out for every item in an array, because you can use a while loop to basically go ball 1, ball 2, ball 3 for you. Any calculation, any operation that you can do with a single variable, you can now do with an array variable. So that is the genius of the array. It basically allows you to automate, make a production line for these kind of operations. So the combination of a loop with an array allows you to do these operations extensively. Now in many ways this shouldn't come as a massive surprise, because if you look at, say, that list, you can just imagine that as a list of numbers in a spreadsheet. So any operation you can think of doing in a spreadsheet, you can actually do with an array. Let's start again. We don't just have to have integers, so let's do one anyway. Let's go int. Start off with a list of students and their scores. That's very traditional. String student names. And if we put the square bracket syntax, we're going to have student 1, student 2, student 3. And we go new string square brackets 1000. We're going to have 1000 students. Yeah, it's just saying it's not used. Let's not worry about that. And then we can say int student score. Let's just call it score for be simple. Score is equal to new int 1000. So effectively we've just created 2 columns, one called student name and one's called score. And we could again just use that syntax to go student name 1 equals Jenny student score, and it's just score now, isn't it? Score is equal to, let's say, 100. And then we can go student name 2 is equal to Rockwood. And student score is 2 is equal to 89. What's it having here? Oh, I forgot to put the brackets in. That's why the underlining was happening. Here we go. Here's my array. So again, anything I can do with a single, if I had a variable string, a student, and a variable score, I hope you understand how you'd use that. But now we can actually look at these things. And it's quite common, particularly in the early days of programming, to have these kind of matching arrays, which if you think about it in terms of a spreadsheet is just two vertical columns. We can, of course, have as many columns as we like. So here's a float, price. I'm just making things wildly up now. New float 1000. So what's the downside of this? Well, obviously the first problem is, supposing I'd made these 100 each, what happens if I go price? So let's just run that. We're going to see that's run. And I've printed anything out, so we don't see anything. Let's just print this out. Print line. Student name. And student score. Like that. There you go. There's Jenny. And if I can do it for 1, I can go int pos equals 1 while pos is less than 2, because I've only got less than 3, because I've only got 2 so far. And I can replace the 1 with pos, because that's the position in the array. Oh, and we're not incrementing. Oh dear. So I made my first mistake there. I should, of course, go pos plus plus, because we need to add 1 each time. There we go. And there's Jenny, and less than 3. Let's run that one more time. And because I can do it for 1, I can do it for as many as I like. I can actually make this 3,000. No, 30. There we go. Now, of course, what's going to happen is we're going to get null because there's nothing in the string, and we're going to get a score of 0 because all of these arrays are initialized with either null if it's an object or 0 if it's a number. And just to prove that, I can go price pos as well. There we go. Now, you saw I made a mistake there and the program went off to infinity. So there's actually quite a handy process that Java does for us. Now, the first thing you know is I've just used the number 30, not the size of the array. So what I can now do is, well, let's do this. Quite often what you'll see people do, back to 3 again, we go string pos name equals that. And you'll see this in a lot of people's code. Int pos score equals that, equals score that, and so on. So quite often you'll see just people doing that, and I'm going to make it as clear as possible, so I'm just going to put that in pos name. Let's get the variables right. So let's look at this code. It starts off with pos is equal to 1 while pos is less than 3. Get the value, so student 1, student 2, student 3. We're going to put that in a temporary variable and we'll print it out. There we go. Now, Java actually provides us with a much better mechanism, a much easier mechanism. We go for, now we're going to go string pos name, colon. And that's not a semicolon, that's a full colon. That's 2 dots, one on top of each other, and then the name of the array. So let's do student name. Now obviously this string has to match up with that string. If this is an array of strings and this is an element in that array, then this must match up with that. Round brackets. Remember, no semicolon at the end of that line because it's the beginning of a block. And then we go print line. In fact, we just copy and paste that. Pos name. So I'm just going to disable all this code. Let's just disable that. So that's all now in a comment, so it won't operate, and we're just going to look at this code functioning. Let's run that. What do we get? We get 1,000,000 nulls because it's now going through the entire array for us and printing it all out. If I do an array of, say, 5, we'll see it a bit better. There you go. It prints out null, Jenny, Rockwood, null, null. So it's basically it's done it 5 times. So this is quite useful because it does all the work for us and it never under or goes over the array. What do I mean by all that? So let's forget looping for a second and let's go back to accessing it. This array of student names, let's get rid of all this gumph. This array of student names is 5 long. What happens if I go, say, 6 million equals Jenny? Now that array only has 5 cells in it. So student name, and I'm putting that value in there. Let's see what happens. If I press go, it compiles, but then I get an array index out of bound exception. That basically says you've asked for an element outside the length of the array. So that basically tells us we've gone too far. Equally, if we did minus that, let's do -1. Yep, index out of bounds exception -1. We can't have the -1th element of the array. But there is something that C introduced, and then all the languages derived from C have the same thing, which is, if you remember originally we had ball, int ball, and int ball1. And again, I've seen that huge amounts of times in students' code. Effectively, we're going int ball 0. So the first item in the array is actually always the 0th element. So if we do that, nothing happens. But if I go print line, print array, student name, if I run that, you'll see it will print out the 0th item is Jenny. And if I do this, just to prove there is nothing up my sleeve. There we go. So how, if we want to avoid the errors like the overwriting error, like that one, how do we know if there's too many items in the array? Well, the array actually comes with a very handy item, which is very unique, which is you go length. And this tells you how big that array is. So if I run it now, you can see it prints out 5. If I make this array 500 big, it prints out 500. But notice I can access, it's got 500 elements including the 0th element. So I can access elements from 0 to 499, not 500. Let's just do that. So let's go print line. Let's see, student name 0 equals Jenny. That runs fine. The 0th item exists. Oop. And let's print line student name 0. Jenny. There we go. And we can, but if we access 499, the last item in the array, equals Kayla, that's also fine. That's good. But if we try and access cell 500, and we run that, the array crashes. Okay, and I think that's about it, at least for the beginning of everything you need to know about arrays. If you have any questions, leave comments at the bottom. Thanks a lot.